All right, welcome back. So let's first off solve this the first way that we said we would by turning both of our denominators into twelfths. So to turn a 4 into a 12, you must multiply by 3. To turn a 6 into a 12, you must multiply by 2. So we get 9 twelfths minus 2 twelfths, which gives us 7 twelfths. Just some reminders of things that we've talked about. Our numerator is prime. So remember, if your numerator is prime, that means that the only way to simplify it is if it fits evenly into your denominator. I hope y'all remember that. No, it's just a trick and gives you a reason to remember what prime's all about. Remember, a prime number is any number that only has two factors, 1 and itself. So the only two ways to make 7 are 1 times 7 and 7 times 1. But okay, so 7 twelfths was our answer. Now let's go ahead and try this a different way. Let's do this if we turned our denominators into 24ths. So first thing we're going to do is multiply by the opposite denominator because that works too. So since this side was sixths and this side was fourths, all you have to do is multiply by the opposite denominator. All right, so that turns our fraction problem into 6 times 3 is 18. 6 times 4 is 24. 1 times 4 is 4. 6 times 4 is 24. So we have 18 24ths minus 4 24ths. And now you can see why this way isn't as easy to look at because, we have an even numerator and an even denominator. That means that the teacher in the room has to dab because it is so cringy to see an even numerator and an even denominator, right? So, thank you. So what we're going to do is anytime we have an even numerator and an even denominator, we know that we can divide at least by the number 2 because all even numbers can be split into two groups. So 14 divided by 2 is 7. 24 divided by 2 is 12. And look at that, we have 7 twelfths once again. And we know that 7 is prime. So it doesn't fit into 12 evenly. So we have solved this problem as best we can. Congratulations. On to the next one, which is dot. Oops, there we go. Okay, we're going to have to rubies this one. On Monday night, Wendy spent one. Actually, why don't y'all do this one? All right, so I want you to think about it. I want you to read it and reread it. And then think about what you're going to underline, what you're going to bracket. Um, Identify your key concept. We can't eliminate bad answers on this one, but we can solve and check. So go ahead and do that, and then we'll check in a second. Cool. Hi, welcome back. All right, so let's rubies this. On Monday night, Wendy spent half an hour on her math homework. On Tuesday night, she spent 3/4 of an hour on her math homework. Remember when y'all had math homework? Yeah. Uh, Y'all are lucky. I used to have math homework for. Okay, I'm going to stop getting distracted. How much longer did Wendy spend on her homework on Tuesday night than Monday night? That's the question. That's what we have to answer. I should read it twice before underlining my question. So, on Monday night, Wendy spent half an hour on her math homework. On Tuesday night, she spent 3/4 of an hour on her math homework. How much longer did Wendy spend on her homework on Tuesday night than Monday night? So, our important information is half an hour on her math homework and then spent 3/4 of an hour on her math homework. Well, you know what? It is important which day. So let's include that information as well. Monday, half an hour. Tuesday, 3/4. So now we bracketed our important information. Identifying our key concept is fraction subtraction because we're going to take our number for Tuesday night and take away our number for Monday night. All right, so 3/4 minus 1/2. All right, and then we can't eliminate any bad answers, but we can go ahead and solve and check this one. So this one's actually a little bit easier than the one we did previously. Remember the trick for what you can do with halves without having to build a snowman. So think about that when you answer this one. It might save you some time, and that's always fun. Time saving, right? And then we'll come back and work on the rest of these things. Okay.